everybody. Welcome. This is my third Law Tech Connect, so I'm excited to be here. And we're talking about future aircraft today. So after 3 years, it's nice to finally have this conversation. We have some really excellent experts on the stage with us. If you guys don't mind, I'll just go ahead and do a little intro for all of you, and if you want to add something. Lisa, I'll start with you. Lisa's a partner at Hogan Lovells. She's a leader and a mentor and one of our nation's top legal minds in emerging aviation technologies. She's also an executive director at the Commercial Drone Alliance and a staple of excellence in the DC area and beyond. Lisa spends a lot of her time giving back and educating, especially to women in drones and lots of other fun organizations. So, Lisa, thanks. Nice to have you. Dan, jump over to Dan Sloat. He leads the Advanced Air Mobility Institute, which is a global nonprofit initiative educating and advocating for the AAM ecosystem. Dan, I found out yesterday, is also educating others. He's an adjunct professor at the University of Arkansas teaching AAM, which I thought was really cool that we're starting that process. I know we've already started it in some other schools, but I'd like to see that go mainstream. Edgar Valdez, he's a senior consultant at Deloitte. He's very knowledgeable in both UAS operations and infrastructure. His history includes time at UPS and then over to the UPS Flight Forward, which is a staple, integral contributors to what we've been doing here in this industry. So nice to have you, Edgar. We have Glenn Lynch, who's the CEO of Volatus Aerospace out of Canada. He leads some amazing teams that are transforming a wide array of industries like agriculture, government, construction, and public safety. And Glenn also has a long career in both manned and unmanned aviation. He's one of 2 pilots on the panel with us today. Last but not least, we have Charlton Evans, who's the founder and CEO of End State Solutions, he's also a crewed pilot, and he's an expert in aircraft certification. He's our go-to around here for waivers and all kinds of certification. Charlton's company has helped many UAS companies get their aircraft airworthy through certification and waiver processes. He's got a great team. So welcome, everybody. We're going to jump right into things today. We have a lot to discuss and not a lot of time. So advanced air mobility, I want to show of hands, is everybody in this audience aware of what advanced air mobility is? Yes, pretty much. We've got a general understanding. That's good. We don't have to go too deep into the weeds. But Lisa, I want to start with you because you're doing so much and you've been doing so much on this field before we really had a definition for AAM. But can you please explain to us and define to us what that is? Oh, sorry.
Thank you, and thanks, Tony, for that kind introduction. Thank you to Don for having me. I'm thrilled to be here with you all, and I know this is a very sophisticated group. So, yes, obviously the Jetsons defined AAM many years ago, but there are a lot of different definitions floating around about it. And I have to say, I haven't necessarily seen the perfect definition yet that captures, I think, what we all kind of would think encapsulated within an advanced air mobility definition. There's the 22 AAM Leadership and Coordination Act, and I'll just share that definition with you all. It's defined as a transportation system that moves people and property by air between 2 points in the United States using aircraft with advanced technologies, including electric aircraft or eVTOL aircraft in both controlled and uncontrolled airspace. Well, obviously, as you can tell, that definition created a lot of confusion, right? Because how do you then draw the line between people, passenger-carrying electric aircraft, for example, and drones when this definition includes vehicles carrying property? Which the previous panel just talked about, right? So there's a lot of confusion there. I think that there's some efforts to maybe improve that in this FAA reauthorization. But the reality is that, and then we want to include, obviously, the electric, vertical takeoff and landing aircraft. What about the companies that are automating manned aircraft? I think they would also consider themselves like AAM. There's urban air mobility. So some of the urban use cases that we hear in terms of easing congestion between LAX and, Pasadena. There's regional air mobility or rural air mobility, enabling cargo delivery, for example, in hard-to-reach areas and with, for vulnerable populations. So there's lots of different use cases. I think for the purposes of our panel, we're all of the above.
Thank you, Lisa, for sharing that. And just for today's purposes, we are going to be talking about the 3 A's of advanced air mobility, which are aircraft, airspace, and airmen. So I'd like to go ahead and Lisa, let me just continue on one more question that I have here for you. What's the national strategy for AAM right now? We didn't discuss that.
Yeah, so one thing I just want to is we dive into what I would consider kind of the FAA, the safety-specific aspects of AAM. Obviously, as we're thinking about enabling AAM in the long term, it's much broader than just the FAA or much broader than just safety. And obviously, safety is paramount, to be clear. But there are many federal agencies with equities in AAM because we're talking about new infrastructure. We're talking about different kinds of security. TSA, other, with passenger carrying vehicles has equities. In this 22 Act, Congress mandated that the federal government create an AAM national strategy and bring together what's known as the AAM IWG, the AAM Interagency Working Group. That group has done a bunch of site visits. Has anyone been to any of these IWG meetings? Excellent. Yeah, many folks. So they've met in Dallas, they've met in New York, they've met in California. They're trying to kind of go out and see, and it's literally 19 departments and agencies who are all working together on trying to identify what are the workforce issues, what are the infrastructure issues, what are the security issues, and put together at least frame out what a strategy might look like. So here today we're going to talk about kind of the safety specific aspects to that, but it is important to note that this is kind of part of a much broader picture, and I know that strategy is being drafted literally as we speak, and hope to see that from the DOT, who's the lead on that interagency working group, later this year.
Excellent. Thanks so much, Lisa. All right, we're going to jump right into the first A, which is aircraft. And I'm going to go a bit out of order today. So let's start with you, Charlton. I want you to just start. We're going to start can you define basic to the crowd, what is an eVTOL?
Yeah, eVTOL, essentially it's this concept of using electrified propulsion to allow aircraft to vertically take off and land, thereby relieving them of the requirement to have a runway or operate out of all the established airports that are currently in use in the U.S. So in other places. So effectively, by doing this eVTOL approach, where you've got a pad instead or a vertiport instead of a runway, it just opens up a host of new areas to fly from. And of course, electrification of aircraft as the propulsion system is key to allowing that to happen without all the fuel infrastructure that exists at airports today as well.
Thanks, Charlton. Glenn, I want to elaborate a little bit with you here on that concept. Can you just explain to the crowd, how does an eVTOL vary from a standard VTOL or helicopters? I know you have a lot of experience operating over the years, and what's your vision on the differences there? Because some people definitely see the same, a VTOL versus a VTOL. Please go into the differences if you don't mind.
Yeah, so I think from a regulatory standpoint, it's interesting because the groups are coming from a different direction. We always refer to piloted aircraft, and we talk about drones, but what we really mean is remotely piloted aircraft. So we're talking about aircraft, period, and then the issue of where the pilot sits, that's the next. Sometimes they're in the airplane, they can't see the ground. Sometimes they're on the ground, they can't see the aircraft, right? And then we have the propulsion system, and those are all different. In some cases, they're woven together. But as a company, we operate a number of piloted gas-powered helicopters and airplanes, and we operate a large number of electric drones. And it's largely because of the size of the aircraft. We have helicopters that we operate that now have electric engines in them, not in our fleet, but they have been electrified. Well, a helicopter is a vertical takeoff and landing vehicle, and when you put an electric power plant in it, it's an eVTOL. And a vertiport and a heliport are an awful lot similar when it comes to the regulatory infrastructure. The difference that happens is obviously the support that's necessary for that asset, what that asset is doing, and so on and so on. But that's really the key thing from my standpoint is an aircraft is an aircraft. Where the pilot sits, that's one issue. And the second one is the infrastructure necessary to support whatever the propulsion system is.
Thanks, Glenn. I'm going to bring our attention really quick to the screen. If you see here, we have a really nice graphic. On the lower circle, the aircraft certification, if you look to the left there, all of those weird numbers, those are parts. Those are our Federal Aviation regulations that dictate the governance of how we certify aircraft. Over to the operation certification, all of those FARs are the Federal Aviation regulations on how we go ahead and operate the aircraft. And there's lots of different ins and outs that we'll all become very familiar with. This is something that anyone who operates general aviation aircraft like myself right now that operates jets, we also use these same Federal Aviation regulations that are going to be used for drones and AAM vehicles. We're not going to be changing those over the course of time. And on that, I also want to add, let me go into, Lisa, I want to ask you a question about what you brought up, UAM versus RAM. I want to dig into that just for 1 second, because regional air mobility is really connecting city to city, if you will, outside, like what I'm doing with my fleet. We'll go from Las Vegas to Van Nuys, California, and we're connecting that with a jet. So that's more of a regional approach, where internal, a UAM approach, if I'm not mistaken, is within a city. Can you define that for us a little bit more and dig that out?
Yeah, absolutely. So I think what we normally kind of think about, a lot of the kind of use cases that come immediately to mind are within cities where we have very congested areas and you're trying to go from one side of the city to the other side of the city, right? And you can imagine that a 5-minute eVTOL ride would be, an hour and a half commute any day, right? So the use case is very, very clear. With regional air mobility, we're talking about, yes, like kind of connecting hubs. And then rural air mobility, I would describe as, outside of suburbs and in more rural areas where there are, not many people. And it's very, very important to be able to deliver supplies, for example. We've seen drones used for a lot of these use cases. So to some extent, if it could be large cargo delivery, for example. And that's an excellent use case as well.
Cool. Dan, I'm going to go jump right to you since we're talking about regional air mobility. And clearly, Dan and Edgar are infrastructure experts on the stage right now. Dan really handles physical infrastructure, and Edgar is more digital infrastructure. And correct me if I'm wrong, guys. So Dan, now that we have a basic understanding, what is the required? There's two different types of infrastructure I feel like we're going to need for both of these, regional and urban. Can you go into both of those for us and the differences?
Yes, absolutely.
Thanks.
So to clarify why, as founder and president of a nonprofit, I would have expertise in the physical infrastructure space. Previously, I served as CEO of an American vertiport company, and there's quite a bit of confusion out there. What is a vertiport and how is it distinct from a heliport? My colleague Glenn kind of alluded to that. Really, it comes down to how it's utilized. Mm-hmm. I think what begets a lot of the confusion is that today, for example, over in Italy, they have what they call a vertiport at Fiumicino Airport, and it really is just a concrete slab with a V painted on, and that doesn't feel like it's worthy of a new term, right? The truth is, in these initial stages, that's largely sufficient to be a vertiport today. At the AM Institute, we kind of look at vertiport development growing with the industry, that it'll kind of roll out in 3 different phases, the first of which being crewed operations. Many of these aircraft will be flown by highly experienced helicopter pilots, so they're certainly more comfortable with landing at modern heliports today. But then when we get to phase 2, which are uncrewed, right, will be piloted from an ops center. We'll need to, along the way, integrate greater and greater levels of real-time infrastructure to vehicle communications. So the sophistication of the technology embedded within that landing infrastructure will start to go up dramatically until we get to finally that final phase 3, which will support fully autonomous operations. Right. So as you can imagine that kind of landing surface will need to have very, very closely integrated technology with the aircraft themselves. So that's kind of in a nutshell how we think about it.
So have you seen, to add to that, just to share with the crowd, have you seen vertiports, other than the one you're saying in Italy, have you seen vertiports going up yet around the world, or are we still just chatting?
So there aren't any operational vertiports yet. The reason that Italy has installed one, they recently got approval to begin operations as soon as December of this year. In preparation for Jubilee there at the Vatican. Okay. There's a lot of, it's more on the kind of ConOps side. It'll be interesting how it develops, but if there's no other takeaways, at least from what I share, a vertiport is not just a slab of concrete with a V.
Thanks so much. I agree. Edgar, let's talk about let's pull off of what Dan said. So how do we have to prepare, the digital infrastructure side of this in order to maintain some safe skies there? We need to keep the NAS intact.
Absolutely. So as important as the actual physical infrastructure is, to really be able to scale the operations, the digital infrastructure really needs to be in place. And we've heard it earlier in regards to it's going to come in a manner of various methods. You can almost think of it as a system of systems approach, where we're going to have the ability to be able to have a UTM system that will be able to facilitate small UAS operations and be able to provide at least some level of actual awareness as we even go into some of the larger aircraft that Lisa was talking about, at least from an AAM perspective. The approaches, departures, there will need to be some level of visibility and intent for those. And to really be able to build that out, it's going to come in a few manners. As some of the work that's currently going on with UTM, but as well as some of the supplemental data service suppliers, as those begin to actually be approved and be able to be leveraged, that'll provide some additional awareness that will be able to be facilitated for these type of operations, as well as we heard, of course, remote ID. So there's these building blocks that are continuing to be etched and be able to be a foundation for a overall system approach and actually allow for that digital infrastructure. And there's still going to be some elements that have to be more so thought through in terms of the roles and responsibilities. Derek mentioned that in regards to yes, probably ATC is not going to be looking at providing individual deconfliction for these aircraft. So these are still these questions that need to be solidified. And so as at least the technology improves, the regulations will continue to evolve to be able to facilitate those.
Excellent. Thanks so much, Edgar. I'm going to finish up our little section here on aircraft with two more questions, one for Glenn and one for Charlton, who are both very experienced in aircraft certification. Glenn, can you give the room here just a quick overview of the process of aircraft certification and why it's necessary? I know that's a very silly question to ask, but we definitely need it answered.
Yeah, Tony, that was supposed to be for Charlton, right?
There's two of them here, so he's going to get the harder one.
Okay, well, I'll keep this one then.
Keep it brief.
I guess a couple of things to think about with aircraft certification. If you think about where drone technologies have come from, they really graduated from two areas. We had, large military platforms, the kind that Don was responsible for protecting over years of service. And then we had consumer, forgive the word toys, but that's kind of where they were born at Best Buy. And then they started to evolve, and the technology started to evolve, and there was a convergence, and drones started getting bigger, and piloted aircraft starting becoming more sophisticated and automated, and so on. So the gap is starting to close. What hasn't closed entirely yet is how the aircraft itself is certified. So remember, I said drones started out on the consumer side with basically the same motors you'd use in a remote-controlled toy that I would buy for my grandchildren. The difference is when you start operating into commercial service, now you've got assets that are being used over and over and over again, and they're not flying 5 minutes a day. they're flying, 15 hours a day. They're not doing 1 or 2 flights. They're doing 1 or 2 flights every couple of hours. And the demands on the equipment are substantial. The reliability testing has to be there. So basically, when they design an aircraft to certify, right, you can design something and say, okay, here's a concept, it flies. That's an experimental prototype. But when you design something to certify, now you're thinking about all the things that we've learned in generations of aircraft. Remembering an aircraft is an aircraft, doesn't matter where the pilot sits. An aircraft, by the way, when we think of drones, we think of small things. There are a lot of very big drones under development in the United States, right here in San Diego. 19,000-pound aircraft being developed for the cargo industry called Nautilus, runs with 2 Pratt & Whitney PT6 engines. It's a big airplane, 85-foot wingspan, and that's an example of where it's going. But those aircraft are designed to standards that were developed for that type of aircraft. Now we take the pilot out of the aircraft. Many of the aircraft elements in terms of reliability testing, mean time between failures and so on, identifying, cradle to grave sourcing on parts, those are all very important things. But then comes the complicated part, which is the technology. How do we remove human beings from the equation? What does that do to the certification process? Because now it's about navigation, communication remotely. Even something as simple as, I was on an ICAO panel recently where they brought up cockpit safety. You don't think about that, right? We can't knock on the door and look at what the pilots are doing anymore because we're worried about aircraft being, compromised in some way. Well, the drone, the cockpit's just somewhere else. So we have to think about the same things in security. But that's basically the elements that I see. From a certification standpoint, we are maturing, though. It was nice to hear about what's happening in India. India, I think, has actually become a real leader in this space, setting some examples.
Thanks, Glenn. Charlton, I'm just going to ask you to add to that if you can talk briefly about the process of certification, FAA side of it, and the waiver side of it, and how is that handled differently from traditional aviation, or is it?
How much time do we have?
You got about 3 minutes for that one.
Yeah, no. Glenn captured a lot of it. Great job. And bottom line is all these certifications, and there are certifications for each leg of that stool, are exercises in trust. And we set levels of reliability or capability through those certifications, and then it's up to the proponent or the applicant to actually meet those levels through demonstration of certification with the FAA and any other civil aviation authority. So that's the bottom line. And the reason that the bar is higher with commercial aviation than it is with private or general aviation is because companies are in it for profit. And as a result, these are guardrails that are in place to avoid companies cutting corners so that they make more profits, but maybe put the public at more risk. So, and aviation is inherently risky. The idea is to get away from pilots and into autonomy, and that's a good way of putting it because it's the same sort of concept, but you can see it flows. You create a product, you operate it under a different set of rules, and then in the case of an air carrier, you operate it under those rules, and the pilots are covered, the aircraft's covered, the operation's all covered. So right now, because this technology is evolving, we have to use waivers and exemptions and special conditions in the certification processes in order to actually get them done because it's not prescriptive, it's not laid out for everyone to go chase. And it's hard to do that because of the wide variance of products, right? You've got little ones, you've got big ones, you've got electric propulsion, you've got conventional propulsion, et cetera, et cetera, et cetera. eVTOL, conventional, launch and land off a runway, catapult launch, net recovery, you name it. All these different operations have to be captured in a certification process. So we have a Chinese menu rule we can use to go do that with, and I promised myself I wouldn't use the word part more than 3 times in this whole, so I'm not going to, but anyway, and then we chase operational waivers and exemptions to go make that work in the airspace. Does that cover it? Yes,
Lisa has something to add too.
Yeah, that was incredibly helpful, both of you. Thank you so much. I just want to say one word about my hope. As you noted, I founded and serve as the executive director of the Commercial Drone Alliance. So we're with the whole commercial drone industry as well as with the AAM industry. And I think there are a lot of ways that these vehicles differ, but there are also a lot of ways that they complement each other. And I do think type certification is one area where I hope we can leverage some lessons learned from the drone industry. And I'm looking at Derek Hufty and thanking him for his great work in flight standards, because do we have any drone manufacturers in the room? Okay, well, okay, yes, we do. Have you gone through the certification process at all or tried? I don't know if I don't know if you want to speak to your own personal experience, but I know it's been challenging generally for the industry. We've had more than 50, I don't know the latest number, companies try to go through the process. Charlton and I actually worked together for one company that did succeed, but so far there's only been, over the last 10 years or so of effort, 2 companies that have actually gone through the process. And so, the FAA is really, really great at what it knows. Regulating, manned aircraft that are piloted. As soon as you start to introduce new innovations, there are challenges. And so, essentially in the drone industry, we had to shift all of the resources that were going into the type certification process to Derek and team. So thank you, Derek, on the operational side, because frankly, it was just stalled on the TC side. And so I certainly want to, now in some ways AAM aircraft are, particularly when piloted, as we saw in the chart, are a lot more like existing helicopters, for example, maybe just electric propulsion. But when they're piloted, so in some ways they're more familiar to the FAA than an 11-pound styrofoam on, remotely piloted aircraft. But that said, there are still certainly some lessons learned there for all of us.
Thank you, Lisa. I'm going to just stick with that side. Sorry, guys, we'll get to you. Don't worry. I know you have a lot to say. But since we're talking about this, I want to just, Charlton, what is the process right now to get certified as a pilot for hire in the U.S.? Like, how much work does that take?
Yeah, so you've got to be a commercial pilot, you have to have 250 hours. You have to already be a private pilot, right? So you go get your private pilot certificate, and then you build up time, you get your IFR rating, and then you apply for, after 250 hours, your commercial rating, and then you get licensed as a commercial pilot. But that's just the beginning. To be an ATP or an airline transport pilot, you also have to have 1,500 hours and take the ATP course. So it's quite a bar, and that's the license to learn in each case, right? Because of the complexities of aviation, the reasons those bars are so high is that because when things go wrong, we expect our pilots to save the day, be that through routine process, emergency procedures, or pulling a miracle out of the air, right? Sully, and et cetera, et cetera. So this is where autonomy comes in, because as we increase levels of autonomy in the product and in the process, the pilots don't have to live up to that sometimes miraculous bar, because the autonomy, if well designed and certified, can do that. So, does that answer your question?
Yes, it does. And you can pass to Glenn, because I want to ask him if there's any differences in Canada, and if he can share any differences between us and Canada, what's going on there.
I want to just add one thing to Charlton's last comment. First of all, I think the key thing has to do literally with the autonomy. That's the one of the major differences, and it's what I was mentioning earlier, is the autonomy in the piloted certified airplanes is increasing. At the same time, the autonomy in the drone world is increasing. We operate right now in pretty much across Canada, across the United States, and in the UK. And funny enough, they're somewhat harmonized. I would say ICAO is having a much bigger influence in this process than they have necessarily in the early days of aviation and aerospace. I'd also say regulators, in my experience, and I know the drone industry doesn't like to hear this, but I think they're moving at warp speed. Right? I come out of a world where the regulations were 15 years out of date when you were trying to change them, and we're still using, Flintstones type technology for navigation. But you know what? They are moving very quickly. They're engaged with industry, and it's not moving as fast as we'd like it to. But the reality is, if it moved as fast as we'd like it to, we probably wouldn't have a super safe environment. So, to our FAA colleague, great work.
Yeah. Well,
hopefully that buys me some brownie points down the road. But honestly, there's the biggest difference that I find in Canada versus the United States. There's definitely some difference in the regulations. There's differences in how those are applied. ICAO has a huge influence because ICAO is based in Montreal, so they've got a huge influence in Canada. They're walking distance to have lunch with all of the Canadian regulators. But the other thing that makes a difference in Canada is we fall in that rural area, and almost more, there's an R, but it's more remote than rural, because everybody in Canada, we have 35 million people living there, and they all live within 50 miles of the US border. So we have this massive area that's unpopulated, or definitely sparsely populated, which allows us to get waivers faster in some cases than we might be able to in other countries where it's tough. You know, you want to fly from New Jersey to New York, it's pretty tough to miss population. But if you want to get from, let's say, Lethbridge, Alberta to somewhere up north, there's nobody there, right? You can go anywhere you want. If you lose a drone, you probably lost the drone because you'll never find it again. But I would say that's the biggest difference.
Thank you, Glenn. I'm going to ask Dan and Edgar the same question, and I'm going to start it off by saying I'm not sure how many people are aware of the crew issue we have in manned aviation right now. We had a lot of people retire during COVID, and we lost a lot of air crew. So because we're starting AAM with manned, with a manned crew, I wanted to ask both Dan and Edgar, I know Dan especially, you travel a lot, what do you think is needed in order to scale the number of pilots we're going to need to accommodate future air mobility plans before we go autonomous?
Yes, so I've read that we're facing upwards of a 60,000 pilot shortfall just to meet the projected demand by 2030. Before advanced air mobility is even contemplated. So I think part of what's fascinating, Charlton did a great job explaining, the sheer extent of the time required to get, qualified and licensed for crewed operations today. In contrast, advanced air mobility, unfortunately, I was in Florida last week, and I'd signed up to fly the Lyft Hexa, a multicopter. It's more so on the kind of entertainment, just kind of the thrill of flying. Unfortunately, it got canceled due to some maintenance, right? Safety first, of course. But believe it or not, they're able to take people off the street with absolutely zero aviation experience and within 1 hour be qualified to fly this vehicle. So they've leveraged, the incredible learnings that have taken place from the drone side of the house with these highly intuitive advanced avionics to produce some very easy to operate aircraft. I think that's very promising. We can. The good news is that even though there's a very high bar to become a licensed commercial pilot today, with advanced air mobility, we expect. There's, for example, Joby's standing up a flight academy. There's a real possibility that we can expedite what's necessary for safe operations.
That's great. Thanks for sharing that.
No, thank you. That's a great question, and I think another piece to add to it is really not also just the pilot. Prior to this, I also did hiring for UPS Airlines, and I saw with the A&Ps, there is going to be a necessary focus to overall really bring in a workforce across all segments within this industry for it to succeed, whether it be A&Ps, whether it be computer software engineers. There's a endless amount of opportunity, and I think from that last panel, it's how do we get the excitement from it? It's this is a very exciting field, and it's also an opportunity to be part of a new industry. In terms of how to really tactically start to build to that. I've seen some great initiatives where some OEMs are already starting to work with some various higher education institutions, whether it be community colleges or universities, to start to build out some of the curriculum for what they may need. We're starting to see some level of focus in terms of from the SFAR, which I know we may go into a little bit more, identifying how maybe we can adjust some of the PIC time to include, as well as we see more type certification, whether or not there may be more commonality and not have to require a type rating for each of these AAM vehicles. So in terms of how to attack the ability to be able to, from a workforce perspective, is definitely be an advocate. If there's someone that shows interest, tell them about this opportunity. This is a incredible industry. It's not just about the pilots, it's also about everything else that's going to be able to facilitate these type of operations. If as an OEM, as an operator, work with your local community schools. The FAA has done some great jobs in regards to starting some initiatives with universities and colleges, and I foresee that be able to continue. You can work with them to be able to, and they're hungry for it in terms of being able to develop new curriculum and develop a new workforce.
Thanks, Edgar. I appreciate that. We're going to close off our chapter there and move right on to Airspace. We're getting close on time here, so we'll just be cognizant of that team. So Lisa, we're going to have you start us off with Airspace, because I'm sure you have researched most of this since you're doing with the Commercial Drone Alliance. What about the FAA's approach? I see what we're discussing here. We're discussing the two plans that came out, the I-28 plan and also the UAN ConOps plan. Can you just go into briefly a little bit about both of those, because those both are publicly available. Don has them linked as well, so we can always revert back to those public documents.
Yeah, absolutely. Thank you so much, Tony. I do want to just build on one thing real quick before moving on, what that Edgar just talked about with the SFAR, so the Special Federal Aviation Regulation, which was released last year. Folks in this room, I'm sure you're all sophisticated. You've read it. You all know about it. Just wanted to highlight a few things the industry is really watching carefully, because we're expecting to see kind of a final rule come out somewhat soon in order to enable this industry to innovate while rulemakings, more permanent rulemakings move forward. Number one, pilot certification. That was a big issue. So streamlining and enabling there to be an initial crop of pilots that are certificated in order to let this industry safely take off while more permanent regulations are designed. And second, the requirement for dual controls. So right now there's a requirement in the SFAR for dual control training, and there are no dual control vehicles. So that was a big problem that was highlighted by many industry groups during the comment process. Just wanted to, share. There were other issues as well, but those are certain things that folks are watching very carefully. Now, on the two plans that you mentioned, the UAM ConOps 2.0 was released in the last year. There's also Innovate 2028. Innovate 2028 was kind of connected with the Olympics, which we're hosting, of course, in 2028. We're thrilled that there is a plan out there. I would say from an industry perspective, if we're going to tie it to a sporting event, the World Cup is next year. The Super Bowl, the World Series, there are many in between. So, I think that there was some concern about tying Innovate 2028 when we want to be able to enable AAM operations in conjunction with the Olympics. With something that's several years out, and I know that there are companies that are ready to go. So, again, the intent is good, but I think from an industry perspective, we're hoping, we think the World Cup provides a wonderful example. Also, Paris, it wasn't really unique because Paris was tying AAM to 2024 Olympics, so that just makes us look 4 years behind France. So, but that said, check out the ConOps if you want to kind of get a better sense of how the FAA, it certainly outlines a crawl, walk, run approach. Everything in there kind of contemplates piloted vehicles using today's kind of ATC system. So it's not necessarily it's not necessarily the future of all this, but it's where we're going to be over the next few years from the FAA's perspective.
Thanks, Lisa. It looks like Don popped up there a nice little graphic of UTM operations and some airspace. So we'll start talking about airspace since that's where we're at. Glenn, how do you currently operate, and do you see a move into the future on the way we operate as far as airspace is concerned?
Definitely. I mean, what happened, first of all, if you imagine when drones first started populating the world, I'm talking the small drones, not the larger defense drones, there were literally tens, if not hundreds of thousands of them flying around in an uncontrolled environment. And basically, it was put on the regulators to say, let's contain this, right? So we squeezed them below 400 feet, pretty much all over the world, or at least in any of the ICAO nations. We moved them outside of controlled airspace. We made them small. Why? Because they might hit somebody, and it all had to do with impact and, you might get hurt, but you're not going to die type of thing. And then because we don't have the pilot on board trying to save his skin by not running into a building somewhere, we needed to make sure that the pilot had to see the aircraft. And that's basically what happened. And now as an operator, as we try to push out operational capabilities and really, expand the use of these aircraft into what's been traditionally piloted aircraft space, we've had to fly above 400 feet. We've had to fly beyond visual line of sight. We've had to fly drones that are heavier. You think about agriculture. It's impossible to spray and keep an aircraft at 55 pounds, right? Your spray product is more than that. So we end up, the operators also participate in the 44807 waivers. They get a 137 certificate to disperse economic poisons, I think is how it's described. But you end up having to really go and right now burden our regulators by walking in with safety case, tell them what you want to do, and then prove to them, demonstrate that you're going to be able to do it safely, right? And it goes back to the same thing, the aircraft, the operator, and the pilot. All of those things have to be addressed. So I'm not sure if that answered the question you wanted.
No, that does. There's definitely changes going on there for sure. Edgar, this is your jam, so I'm going to move over to you to ask you a question about what's needed for the airspace integration and management, digital especially. Is there anything changing in your perspective?
Changing, yes, but really more so evolving. That's how I've really seen this continuing to move forward. Is one of the things that we've seen, especially from at least Dallas, where we're starting to, you've been able to operate and you were able to use various mitigations, such as, let's just say, strategic mitigations, because no one else is really operating. Therefore, if you had your UTM system, you really know the only thing you need to do is just not hit yourself. But now where you're going into a situation where there will be other operators, and therefore really the ability to be able to see their operations, their intent, and be able to deconflict from that, I think is going to be really the next evolution for that. So sort of this common operating picture and the ability to be able to actually see others is not just yourself, is probably going to be where we'll see the scale.
Thanks, Edgar. Dan, you want to add to that from your perspective?
Yes. So previously I served as a captain in the United States Air Force. My role was command and control air battle management. Although we didn't utilize the term UTM, UAS traffic management, that is precisely what I did. To give you a sense, I was personally responsible for orchestrating the navigation of at least 100 drones at any given point in time. And that's across all U.S. branches and our coalition allies. So there's even, to an extent, some language barriers that can lead to confusion. In a combat environment, this is very, very dynamic. When it comes to aviation, historically, we've been able to rely on military-trained pilots to come and support commercial operations. Interestingly, with eVTOLs, we won't have those same kind of resources. I've heard of some potential use cases. Of course, when generals or admirals want to get from an airport to base a little bit quicker, I expect there'll be some of that. But in a combat context, perhaps fully autonomous battlefield extraction is possible. And that's certainly something that we support at the Advanced Air Mobility Institute. We want to, of course, discourage weaponization of these vehicles domestically, even for law enforcement. But while we can't look to the military to provide and supplement pilots for this advanced air mobility space, we will be able to leverage an incredible amount of learnings that's taken place specific to UTM.
Thanks for sharing that, especially from the DoD perspective. Charlton, we're going to pass it all the way down to you to finish this off. I wanted to ask you, as far as, where are we? Hold on, let me find my question for you on airspace. What are the operational rules that apply to these new aircraft, and do they plan to change them as far as you are aware? So I think we're talking about, with that question, is aircraft operations, so what we're doing, what I'm doing. Do you know of any changes coming, or are we going to pretty much be operating under those same rules?
So I should hand the mic to Derek.
Yes, you should, but you see I'm looking this way. I'm not looking here. I'm giving him a get out of jail free.
So we're all hopeful that under Part 108 there are some, it will address some of the ways that we currently have to operate under Part 135 for delivery. Part 91, I don't know that there really needs to be any true changes there right now. I think things are basically covered, and Part 107 seems to be a smashing success. So I think the carriage of people and property for hire is where the changes need to take place. Everybody recognizes that Part 135 is a high bar and has some things in it that probably just need to be applied differently. But changing these rules is no small task, right? Rulemaking is anywhere from 3 to 7 to 8 years is what it takes to get a rule proposed and then pushed through. So Derek and his team are deeply involved in that, and we're all waiting with bated breath to see what comes out of that. That said, there are examples today, and Derek's team is also responsible for this, and I'll jump on the Glenn bandwagon here and thank Derek and his team, because they have really taken both the certification of the airframe or the product side and the certification of the operation side and really streamlined that through exemptions, and that's under that 44807, Section 44807 of the REAUTH bill. So go out and read that thing and know that Derek and his team have taken that and are applying it very aggressively, I might add, to get products and operations through the process in a timely manner. So instead of a 5-year TC process or type certificate process, now you're looking at maybe a year's worth or maybe 2 years worth at worst of working through a product exemption and some waivers and then some exemptions on the operation side to get through all that. All that work is informing what will be baked into Part 108 to allow carriers to go out and operate with a prescriptive set of rules that make sense for the operation.
Thanks, Charlton. We're going to close up. Everybody, 30 seconds of, let me see, where would you like to see this industry in the next 5 years? What would make you happy? And Charlton, go and pass her down.
Yeah, Part 108, call Derek. He's your man.
Call Derek. Yeah. No, actually, I'd really like people to start thinking about integrated aviation, where piloted and remotely piloted aircraft are being operated pretty much the same if they're doing the same type of purpose. If we're doing a surveillance flight using a piloted helicopter or a drone, it shouldn't matter, right? At the end of the day, we're using the aircraft, the platform, and the sensors to do a specific job based on the capabilities of that technology. The same is going to be true with every other part of aviation, right? You're going to have piloted aircraft and remotely piloted aircraft that will be integrated much in the same way that in the early days of the automobile, we had horses. Most people don't know this, but cars were actually prohibited from operating inside of a lot of urban areas because they were disruptive to the horses and dangerous to the people. Today, it's the other way around. But there was a period of integration where horses and cars operated in the same environment. We're getting very close to that right now.
Great. I actually have 3 very quick things I'll talk really fast to say in closing. First, we've talked a lot about exemptions, 44807s. Obviously, those are excellent opportunities for industry to be able to get around, where we're trying to fit a square peg into the round hole. It doesn't fit. One of the challenges with 44807s, and Derek, you would agree with me on this, is that they're actually rulemakings. And so the safety analysis of it is one piece of it, but then it has to go through this whole kind of process through the front office and DOT and others. So one of the things that the Commercial Drone Alliance asked for in the FAA reauthorization, and I think we'll see it because it ended up in both bills, is the opportunity to make a 44807 process actually a waiver process. That will, I think, make Derek's life a lot easier, and that was definitely the hope. So May 10th, we'll likely see the final FAA reauthorization. So look for that. That would be huge, and that was one of our big priorities for the year. For the reauth from the Commercial Drone Alliance perspective. Number 2, we've talked a lot about challenges. I think it's important just to, we are all excited about the great opportunity from an industry perspective. We want things to move faster. The policy is obviously lagged behind the pace of technology. It's always important to note that there are really great people at the FAA that are trying really hard to fit the square peg into the round hole. Part of the challenges are really systemic, right? The rules are they just don't necessarily always fit. Sometimes they do, but sometimes they don't. There's a lot of frustration. These are good people that are trying hard. So, we just have to kind of keep that in mind as well. And help them. Part of our responsibility as industry is to help them understand what is the future of this marketplace? Where is the technology going? How can we help educate so that we can all kind of move forward together? The last final, I've talked about lessons learned from the drone space. The last final note I would have is that the national security agencies had a very strong seat at the table in terms of how quickly drone integration moved forward. My expectation is that they will be heavily involved as well on the AAM side. We want to include the national security agencies sooner rather than later so that we're not having, like in the drone space, the national security agencies came out and said, well, no expanded operations until there's remote ID and counter-drone authorities, which, by the way, are congressional. And, and it literally halted commercial drone integrations for 5 years. We don't want to see that in AM space. So note to all of us that we should be working with the national security agencies now. Thank you.
Thanks, Lisa.
Perfect. I think probably the biggest thing I'd like from a takeaway, or what I would see as future vision, is making sure that AAM is part of like the actual overall aviation ecosystem. You can't think about it as separately from it, one or the other. It's as I mentioned, it's an evolution in terms of my mindset for aviation, and so therefore I see AAM as even broader in terms of just even thinking of some of the actual new avionics systems that we're starting to see by a lot of the OEMs that I think will transition from potentially where you're seeing in Jobies and the betas that you may start to see in your actual wide body or narrow body aircraft because of the automation that they're going to be able to provide. So think about it that way, and I think that will help in terms of from an integration perspective.
Thank you. First, I want to say, Tony, fantastic job moderating today. So when I think about this space, fast forward 10 years from now, it's really, I think, a fascinating and realistic possibility that right by 2034, we may already have fully autonomous operations. For any of you that aren't aware, over in China, in the final days of 2023, they did type certify a remotely piloted eVTOL. Right, so these are already flying in a commercial capacity in China. At the AM Institute, we've done an incredible amount of outreach to build up our board of liaisons. In fact, shout out, we have our liaison to Switzerland in the room with us today. We have representatives now in 50 countries. And what's really exciting about this is four countries that maybe are a little more ambitious and they want to kind of take a lead in this space and try new things. We can learn from that, right? We can gauge how are people reacting. What's the kind of the evolving public sentiment towards this technology. And so we're trying to gather that. We have a semi-annual virtual conference, the Global AAM Forum. Next iteration will be in late July. And so we look to our liaisons to give us a sense of how people feel about this. Are they ready? Because this is going to be a truly monumental shift, right? Throughout human history, regardless of the mode of transportation, we've always relied on an experienced operator, right? A trained conductor, a ship captain, an airline pilot. And so to ask people to put their lives in the hands of an algorithm, that's big. And so at the AM Institute, we're working very hard to make sure that when it comes to public acceptance and ultimately public trust, that we navigate that very carefully. So if any of you are interested in learning more and supporting our efforts there, aaminstitute.org, we'd love to have you.
Thanks, Dan. Okay, I think we're closing up. Wanted to thank everyone for joining us today, and safe skies, everyone.